Push the button.
All right. So a businessman stands on a bathroom scale in an elevator, which is not moving. All right. So we got the sweet elevator right here, the sweet face, boom, little bathroom scale going on. Businessman. All right. The scale reads 500 newtons. So right here, force of gravity is 500 newtons. The elevator then accelerates downwards at 2 meters per second for 10 seconds. What does the scale read during the acceleration? And also, how far does the man travel in the elevator? Well, first off, we know that we got our original equation: force equals mass times acceleration. And the sum of the forces right here is force normal minus the force of gravity, which is 500 newtons, is equal to the mass of the man, which the way we figure that out is we're going to do a little bit of a conversion over here. So we're going to go 500 newtons, then divided by kilograms over 9.8 newtons, which is going to give us 51.02 kilograms. So that's the mass of the man. 51.02 times the acceleration, which is 2. Alright? And so what we're going to do is we're going to add this 500 newtons to this side, and we're going to get we're going to end up getting 500.
Good job.
Thanks, bud. Force normal equals 397.959 newtons. All right.
Looks cool.
Thank you, bud.
Welcome.
So right there, that is the force normal when the that's what the scale reads during the acceleration. So then also, how far did he travel? We're going to use the equation for distance, which goes distance equals velocity, initial velocity times time plus 0.5 times acceleration times t squared. So plug in all our variables. So the initial velocity was 0, so this is going to cancel out right away. And we're going to go equals 0.5 times 2 times 10 squared. And now let's do some unit analysis to make this a little bit more easier to see. Is equal to 1 over 2, which is a half.
Cool.
2 meters per second squared. And then 10 seconds squared. So these units are going to cancel out right here. 0.5 times 2 times 10. That's equal to 10 meters. Right there. Boom. So, and we have the distance that it traveled.
You're doing it like the rhyme I know.
Oh, yeah. So let me give a little explanation real quick. When the elevator is not moving, there's only 2 forces acting upon it. The force of gravity and the normal force, and they are equal to each other. That's the sum of the forces. Once the elevator begins to move, the elevator is actually letting gravity win. The acceleration of gravity never changes, so the force of gravity doesn't either. What changes is the normal force. We know Newton's third law: the sum of the forces equals mass times acceleration. So, so the force normal minus the force of gravity equals mass times acceleration.
Good job. Good.
In the end, that is the physics problem. So, physics. All right, stop.